So hello everyone. Before going to our main experiment, let's see some basics of the FSK. So we already know that we have different kind of digital modulation, like the amplitude shift keying, on off keying, then the frequency shift keying, and the phase shift keying. Now we'll talk about this frequency shift keying. So how it works actually. So suppose you have a satellite in the space, and from that satellite you need to send some data to the ground station. So your ground station is in the earth, so we have to link, or we have to send, or we have to transmit or receive data from satellite. So from satellite you have a microcontroller, and that microcontroller will take pictures, and from that pictures let's take fast 8-bit stream. Suppose you have a 8-bit stream of 10111011. So this is the 8-bit stream, and you have to send this data to the ground station. That means your earth station and satellite side. So how you will send it, because if this pattern has a very low frequency, so if you want to design an antenna for this one, then the antenna size will be very big. So that's why, to reduce the antenna size, what we can do, we can increase the frequency. So in frequency shift keying, how that is working, first of all, let's draw the bit pattern. So first is 1, so this is high, then low, high, high, then low, again, then goes to high and high. So this one, so we have 1 0 1 1 0 1 1. So let's draw a line over here. So as the name suggests, it's a frequency shift key. So we will do some changes in the frequency in the modulation. Suppose in frequency shift keying, what is happening, like for the high part we have a very high frequency, let's assume at 5 kilohertz frequency. Okay, so the 1 bit will be transmitted in high frequency, very high frequency. Okay, and the this 0 part will be transmitted with a very low frequency, or let's assume this is 1 kilohertz, just for example. So okay, and again we have high, again we have high to 1, and then again low, and then again high frequency. Okay, so that's the actually basic. So you have, when we are sending the zeros, we have low frequency, and when we are sending the high, we are sending the high frequency. So this is the basic of the FSK. So frequency shifting, we are shifting the frequencies according to our digital data stream. So in reality, how we can do this? So for the frequency shifting, like this is our master signal, and you can understand that we have actually two kind of carrier. One is in high frequency, one in low frequency. So we need two carrier right now. So first of all, we have the empty message signal. Now we have to send this message signal with two carrier. Okay, so we will modulate with this one, the main message signal. Okay, and another one is from here. Now for this one we cannot multiply with 0 because it will become 0. So what we need to do, we need to invert this signal first. So we need an inverter, and then it will go for modulation with our carrier frequency. So we can like modulator 1, modulator 2, inverter. So this data will come here 1 0 1 1 0 1 1, and another, the carrier signal will come, like the carrier signal may be something like that, A cos twice pi f. F is the frequency here, so f for 1, okay. So it can be your carrier signal. And for this one we have, if you inverted this data, it will become here 0 1 0 0 1 0 0, and from here we can add a carrier. The frequency will be different here. Okay, so now after this we have to combine these two signal. So we have to add these two signal, and this will be our modulated signal. So what is happening here, actually after this point we are getting this kind of signal. So first one, and then we are getting 0, then again 1, again 1, then we are getting 0, then again 1 1. Okay, so we are getting this kind of signal from here, and from here we will get first 0, then low frequency 1, then 0 1 0. So that was our target, and if you add these two signal, then we'll get the total signal. So here is high frequency, then low, then high, then low, again high, then low. So that's how we actually do the modulation for FSK. Now we have to think about the demodulation part. So here you can easily see that this is 1 this is 0, this is 1 1, this is 0, this is 1 and 1. So this kind of pattern. So where we are having 0, we are getting the low frequencies, and where we are having 1, we are getting the high frequency. So let's talk about now the demodulation part. So for the demodulation, actually we have the frequency of the modulation. So we have so this is the signal. Now we have to actually detect the signal first of all. So what we need to do for that, so this is one kind of detector, is another you can call it synchronous detector. So first of all, we have to multiply this signal with the same carrier frequency. So first of all, we have for carrier frequency for 1, we have that a cos this one, and for 0, for carrier frequency which are carrying zeros, so that one we have cos. So this is one kind of detector. So now what we need to do, we actually detect this signal. Now we have to use some low pass filter, because we have some other frequencies, maybe some from the environment there will be some noises, so we have to filter out that thing, and we have to collect only the data stream. So for that we have a low pass filter, LPF, here and again here. So after that we will get some signals. Then what we need to do, we have to, because this is for 1 and this is for 0, now we have to minus this data from each other. So this signal is for 1 and this signal is for 0, so here will be plus and this will be minus, and we'll get some data over here. And now we have to compare this data with respect to 0. So then we will get the demodulated signal. Okay, so here actually the signal will be very noisy, and so after LPF, low pass filter, the one will be like something like this. Our data stream was 10111011. So for here 0 1 1 0 1. So this is 0 actually, and here we will get something like this. One, all the zeros will be 1 over here. Okay, so now if we, like, this is 0, this is 0 level, so if we minus this signal from this one, then in this point what we will get something like this. So this is 0, actually this point is 0. Okay, so now we are using some comparator. So now here maybe depend on our A, we will have some amplitude over here and here. So this is in positive side, this is in negative. So if we compare it to 0, like if the data is greater than 0, greater than or equal to 0, we will have 1, otherwise we will have 0. So after this comparator we will have this exact signal that we actually transmitted from the satellite. So like this. So first of all we have some delay actually, so from that one, so first 1, then 0, then 1, 1, then 0, then again 1, 1. Okay, so here is actually our demodulated signal, and if we see from the beginning that we sended some data like this one, and at the output we are also getting this signal. So this is our whole process. So from satellite we are sending this data, and these are taking after this kind of processing at the ground station or in your home, you are getting this data with some delay factor because of we use some low pass filter and some other things. So depending on your low pass filter designing, the delay will be long or short. So you have to design the LPF very carefully. So this is actually the full process of our FSK. Now we will do this thing in the Simulink part.